Yes, welcome back to another presentation, which is lecture number 26, in which today I'm going to explain you about the time response of a first order system for unit ramp input. We will see the time response of a first order system for ramp input, or you can say unit ramp input signal, you can say. So what is the time response? What is the time response of first order system for unit ramp signal? In our earlier class, means in our earlier presentation, we have seen the time response of a unit step signal. There we have seen that as the time is going on, as the time is going, or as it approaches to infinite, and your value c of t, okay, c of t, we have seen it is also increasing. Okay, initially it starts from 0 and slowly it is reaching to your final value, means steady state value. That's what we have seen in previous presentation. Today I will explain you the same for ramp input signal. Okay, time response of a first order system for ramp input signal. So let us recall that quickly. We know that the first order system can be identified as like this. This is your R of S, and then this is what your C of S, and then it is 1 by 1 plus T into S, or otherwise S into T. You can write anything, no problem. Either you can write T into S, or sometimes you can write S into T, no problem. And from here, from this, C of S by your R of S is equal to C of S by R of S is equal to, it is 1 by 1 plus S into T. So this is what the basic transfer function of a first order system. This is the transfer function. C of S by R of S is equal to 1 by 1 plus ST is the transfer function of a first order system. So in this transfer function, this is 1 is the numerator, whereas 1 plus ST is the denominator. If you observe in denominator, so it is the quantity, or it is the parameter in S. So this is called, you can write ST plus 1 also, no problem, ST plus 1. So normally your expression will have is in the form of either S square plus S plus some constant, or sometimes S plus 1, or you can say S cube and so on, so S square, something it should be like this. Say for example, if the denominator part is in the form of S square, if it starts from S square, then that is called as the second order equation. The order is obviously identified or expressed by the denominator term, not numerator. In denominator, so your S that depends on S, the power of S. The power of S indicates the order of the system. Okay, that I will explain you a little bit in the next slide so that you can better understand. So the power of S in the denominator for the given transfer function gives the order of the system, where in this 1 by 1 plus S plus 1 by 1 plus ST, 1 plus ST is the denominator. It is the 1 is the numerator, 1 plus s is the denominator. So in the denominator, what is the power of s? S power is 1. That is why it is called first order system. Clear? It is the first order system. Say for example, if it is square, then it is called second order system. And if it is cube, then it is called third order system. Like that. So the denominator part of the given transfer function means the power of s defines the order of the system. Clear? So this is what the transfer function basically. This is what the transfer function. From this, actually, C of s can be written as C of s is equal to, what is your C of s? Take this R of s to the right side, then what it will becomes? 1 by 1 plus s into t, clear, into R of s. Is it not? So, just I want to write the expression for C of s from this transfer function. Okay, C of s is equal to, then your R of s goes to the next, right side, then it comes in the multiplication part, means R of s. This is what your C of s is equal to now. This is what your C of s. This is what your output C of s in the Laplace transformation form. Now my input is, what is my input? Ramp input. Ramp input. Now I am considering my input R of s as ramp input. So what is the ramp input? What is the definition of a ramp input? We have seen in previous presentation that what is the ramp input and what is the Laplace transformation of ramp input. Your ramp input is nothing but ramp input is R of t is equal to simply, actually it is a into t. We have seen this is for t is greater than or equal to 0 and it is 0 for t is less than 0. We have seen already. But as we are considering ramp input, in this special case we are considering that is unit ramp. If it is unit ramp, your magnitude becomes 1, means your a value is 1. So consider for step, okay, unit ramp, not step, it is unit ramp for unit ramp input. For unit ramp input, your R of t is equal to, a becomes 1, obviously we will have t only. This is for t is greater than or equal to 0 and it is 0 for t is less than 0. T only. Okay. This is what unit ramp is defined like this. R of t is equal to t, that is for t is greater than or equal to 0. Means from 0 to plus infinity you have t and for less than 0 you will have 0. Now what is the R of s here? So if you apply the Laplace transformation for this, then R of t becomes R of s. Then what is the Laplace transformation of t? It is 1 by s square. This already I have explained in previous presentation. There is a one property we have seen actually, that is the Laplace, the one of the important property of Laplace transformation, that is L of t power n is equal to n factorial by s power n plus 1 factorial. From this definition, means L of t power n is nothing but here t only, means power is 1 only here. Therefore, this is equal to 1 factorial by s power 1 plus 1. This is 1 by 1 plus 1 square, 1 square. This is what your Laplace transformation R of t. So the Laplace transformation of R of t becomes R of s and Laplace transformation of t becomes 1 by s square. Now your R of s is nothing but 1 by s square. You must substitute here. Substitute this R of s equal to 1 by s square value in this given expression C of s. Then your C of s becomes, following, your C of s becomes, so your C of s output, C of s is equal to, I will write like this. You can also write like this also, R of s into actually 1 by 1 plus s into t. Is it clear? The same, that R of s I am just writing before this, actually R of s into this one, nothing wrong in that. So now what is your R of s? Your R of s the ramp input. So for ramp input, R of t is equal to t. What is R of s? It is 1 by s square. Clear? 1 by s square is equal to 1 by 1 plus s into t. This is what your C of s. Now, as per your mathematical definition of the partial fraction method, you can adjust, or you can write this expression as, you can write in partial fraction method, then it can be written as a by s square. You can write like this, plus 1 plus st form is there, then definitely it will comes b by s plus c by 1 plus st. I think you already know this. This is what the partial fraction method. If you, okay, this can be written as in partial fraction like this, a by s square plus the s term will also come, basically as it is the second order, then s term will also come, then c by 1 plus st will come, and from this implies what you can write. So this is equal to, here if you take okay, if you substitute this, if you simplify this, you will have s square by 1 plus s into t, basically, okay. Then what you will have, basically, if you simplify, take, so a into 1 plus st, is it not? If you multiply this s square with this one, s square will be out, then a into 1 plus st will be there, clear, plus if you multiply this s to s, then there is 1s, and in this 1s will be out, then s into what you will have, so s into 1 plus, is it not, st of b will be there, plus c, so it is 1 plus st, so this will be there, and s square into c, so means c into s square, clear. So this is equal to this one. What is this actually? What is this actually? 1 by s square 1 plus s into t. This entire 1 by 1 into 1 1 s square by 1 plus st is equal to, so this is your partial fraction, this thing. So if you equate this LH side is equal to RH side, then these two will be cancelled out. Denominator part both will be equal. Then if you equate the numerator part, this entire equal to 1. Is it not? Then this entire means a into 1 plus st plus s into 1 plus st into b plus c into s square is equal to 1. Clear? So from this you need to find out what is the value of a, what is the value of b, what is the value of c. We have to find out, and then substitute those a, b, c values in this expression. Okay. Now, so means you equate this one, then these two already cancelled out, then this entire is equal to 1. So, so therefore means in the next step, what you will do? This implies 1. This one is equal to, what is that? A into 1 plus s into t plus s into 1 plus s into t of b plus c into s square. This is what the thing, basically, after this cancellation. Clear? Now what we will do, in order to find out a, b, c values, our target is to find out the value of a, value of b, value of c. We have to find out from this expression, and a, b, c values should be applied in this expression. Now how a, b, c can be obtained? So the value of a can be obtained that you equate the constant terms on both sides. This is the left hand side, this entire is the right hand side. This is the right hand side quantity, this is the left hand side quantity. Equate the constants on both sides. By equating constants on both sides, constants means not the s terms, only constant term. So in the left hand side the constant is 1 is equal to, on the right side what are the constants? A into 1, a into st, it is not constant, that is term of s. Here s plus 1 s, so here there is no constant here, only a into 1 a. A into 1, A is equal, so on the right side, your constant is A into 1, A. That is one the constant on the right hand side, and obviously 1 is the on left hand side. Means that your value A is equal to 1 is the first value. Okay, A is equal to 1 is the value of A is 1 by equating the constants on both sides. Clear? Now, what we should do? Next, equate the S terms on both sides. Equate the S terms on both sides. So, already we got A is equal to 1. Just you note down somewhere. A value already 1. You obtained A value as 1. Clear? Now, I erase this. Now, what we will write? Equate S terms on both sides. If you equate S terms, what is the left hand side? Is there any S term here? No. Means obviously you will have 0 here. 0 here because no S term here. And on the right side, so what is the S term? So for equating S term, you substitute A value 1. Already you have obtained A is equal to 1. That 1 you substitute here. So if you substitute that value, it comes 1 obviously. You substitute A value here. Now what is S term actually? What is S term actually? Or otherwise we can substitute A value later also, no problem. You write first S term. So if you S term is equal to A into T. Clear? A into S term means A into T is the S term here. Here plus what is S term here? B. Is there anything else? S into S square. Here S square is there. Therefore, so then this is what actually, if you equate the S terms, clear? A into S into T. A into S into T means S into AT. S coefficient what? A into T. That's what here. A into T. Plus. Then here, what is the S term? S into B means S coefficient B will come actually. S into 1 into B na. Therefore, S coefficient means B will come here. So, here S square. So, that is not our interest now. Means AT plus B is equal to 0. Now, substitute your A value is 1. You already know A value is 1. Therefore, if you substitute, this implies this further A value is 1 because 1 into T plus B. This is equal to what? T plus B equal to 0. This 0. Therefore, what is B value? From here, B is equal to minus T. What is? B is equal to minus T. You have B is equal to minus T. That is the B value. Clear? Now what we will do? So we have equated the first constant, we have equated. From there we have obtained A value. A is equal to 1. Next we have equated the S terms on both sides. Now equate the S square terms on both sides. So in the left side, what is the S square term? Is there any S square term on the left hand side? No. Therefore it is 0. Again, this implies, right side, what is the S square term? Is there any S square in this? No. So therefore no coefficient in this. So in this term, what is the S square term? S into S square means T into B. This means TB. You have T into B plus what is the S square term here? C means C plus TB equal to 0. Clear? So C plus TB equal to 0. From this equation, 0 is equal to what is B value? Already minus T. Therefore, T into what is B value? B is minus T. Substitute that B value here plus C. This implies 0 is equal to T into T minus T square plus C. Clear? From this, what is C value now? Tell me. What is the C value from here? This implies, obviously you can write C is equal to, what is that? T square. What is? C is equal to T square. Clear? Means you have obtained a value, you have obtained b value, you have obtained your c value also. Now substitute a value, b value, c value in this expression, in the c of s expression. Then c is equal to t square. Now write that c is equal to t square here. C is equal to t square. Substitute these three values in this c of s expression. Then what you will have? This implies what you will have? C of s is equal to, forget about this, okay, no problem. A, what is a value? 1, means it is 1 by s square, plus what is b? B is equal to minus t, therefore minus will come here, that is minus t by, it is s. Clear? Plus what is c value? It is t square, right? T square by 1 plus s into t. Clear? This implies, now you can do one thing, one small modification. It is 1 by s square, you write as it is in the next step, by t by s. Clear? Plus t square, let it be t square there. Now in the denominator take t as common. If you take t as common, then it comes s plus 1 by t. Clear? S plus 1 by t. Now if you take this t to the denominator, this 1t and this 1t will be cancelled out. 1t, t goes here. Then this equal to, it is 1 by s square. It is 1 by s square minus t by s plus 1t will be there, s plus 1 by t. Clear? This is what your c of s. This is what your c of s. Now this is what your c of s. Now for this, what we need to do? This is the c of s in Laplace transformation. Almost all we came to the conclusion. This is what your c of s. This is in the form of Laplace transformation. Now you apply the inverse Laplace transformation to this expression. You apply the inverse Laplace transformation to this expression. Then you will have, apply the inverse Laplace transformation. So in our earlier presentations, I already explained you that L of t, Laplace transformation of 1, is nothing but your 1 by s. Remember, L of t of 1, if you take the Laplace transformation of 1, that gives answer as 1 by s. And if 1 by s is there, if you take inverse Laplace transformation for this, means inverse Laplace transformation of your 1 by s. If you take inverse Laplace transformation, nothing but your answer is 1. Means wherever you have 1 by s, means here 1 by s is there, no? You apply the inverse Laplace transformation first. Then I think you will understand better. By applying, write this, by applying inverse, what? Inverse Laplace transformation, inverse Laplace transformation, then that means that LT of inverse of c of s, this equal to, means this one, for this c of s you have to apply LT inverse, means inverse Laplace transformation of c of s is equal to, for entire you apply LT inverse, means LT inverse means inverse Laplace transformation of 1 by s square by t by s plus, it is t by s plus 1 by t. This is what, okay. Then I will erase this. And finally this implies, actually LT inverse of c of s, if you take c of t, then if you take Laplace transformation to the c of t, then it becomes c of s, no? And for the c of s, if you apply inverse Laplace transformation, then it becomes c of t. Means what is the inverse Laplace transformation of c of s? C of t. Clear? Then it is called C of t. If you apply inverse Laplace transformation to this C of s, then it is C of t. It becomes a C of t. Now here these are three terms are there, means LT inverse of 1 by s square, clear, minus LT inverse of, I am writing separately these three terms for your better understanding, LT inverse of t by s plus 1 by t. Clear? Separately, individually I am writing LT inverse of this minus LT inverse of second parameter plus LT inverse of third parameter. Nothing wrong. Now, tell me, what is the LT inverse of 1 by s square? LT inverse of what is s square? So, if you take the Laplace transformation, if you remember Laplace transformation of t, okay, Laplace transformation of your input, ramp input, what is the ramp input? R of t is equal to t now. Then what is the Laplace transformation of t? It is 1 by s square, no. 1 by s square. It is R of t. Your R of t is nothing but t. So for the R of t, you are taking Laplace transformation, means Laplace transformation of your R of t, nothing but t, that is what? 1 by s square. If you take inverse Laplace transformation to 1 by s square, then the answer is t. Therefore, here, what is the answer here? T only. Small t is the answer. LT inverse of 1 by s square, nothing but small t, minus. Now, so capital T is the time constant basically. Take this t as outside. Take this t, capital T as time constant. Take outside, means then LT inverse of 1 by s. LT inverse of 1 by s. What is LT inverse of 1 by s? Tell me. What is LT inverse of 1 by s? If you take Laplace transformation of 1, the answer is 1 by s. The Laplace transformation of 1 is 1 by s. Okay. Then if you take inverse Laplace transformation to 1 by s, the answer will be 1. Okay. If you take the Laplace transformation to the 1, the answer is 1 by s. And if you apply inverse Laplace transformation to 1 by s, answer is 1. Therefore, inverse Laplace transformation of 1 by s. What is the answer? 1. Therefore, 1 actually, t into 1 is nothing but t only. Is it not? T into 1 basically, it is t only. Plus, so this t only, 1 by s, LT inverse of 1 by s is nothing but 1. Clear? Now, again here t is the, your, time constant, take outside here. Now tell me, LT inverse of 1 by s plus 1 by t. Have you remembered this? This is another important property which I already explained in the previous presentation. So you must follow my presentations in order to have the better understanding, because as I am going in on means in a sequence, that's why you need to follow that. Okay, means it is LT inverse of 1 by s plus 1 by t. This is what we have to find out. There is a property of Laplace transformation. What is that? Laplace transformation of e power at. I already explained in last presentation. Laplace transformation of e power at is nothing but 1 by s minus a. And similarly, Laplace transformation of e power minus a into t, 1 by s plus a. It is 1 by s plus a form. 1 by s plus a. What is a? 1 by t. A is nothing but your 1 by t. Then if you take inverse Laplace transformation to the 1 by s plus a, obviously your answer is e power minus at. What is a here? 1 by t. So substitute this formula there. This formula there, because for s plus a form is nothing but e power at we have to consider, minus at, not this one. Not this one. So e power minus at. Therefore, what we will have here? E power minus a nothing but 1 by t, at small t. This is what your answer. This is what your answer. C of t. This is what the response. This is what the time response. of your unit ramp input for a first order control system. So C of t is equal to t minus t, means you can write in a bracket here, no problem. You can write t minus t and plus of t into e power minus 1 by t of t. So if you, this is what the response. So in academics, normally it will be it will be important in your academics. Basically, I think in the competitive examinations they may not ask you about this. For examination, I mean academic point of view only, I am explaining this. Sometimes they may ask you that. So derive the expression for time response. Derive this is what derivation or obtaining. So obtain or otherwise derive the expression for the time response for the first order control system for the given ramp input signal, unit ramp input signal, or okay. So then you have to show this expression, you have to derive this like that. Okay. So from this C of t is equal to t minus t plus t e power minus 1 by t. So if you show this, so this is what basically your, this is what the transient response here. This is called your transient response, because each response, each time response has two parameters: transient response, steady state response, as we have discussed in our previous presentation. So this e power minus 1 by t, this form is called as transient response, and this is called your steady state response. This is called your steady state response, And if you draw in a graphical presentation, if you draw this in the your graphical, it is simply like this. This is what basically t, this is what your C of t. Normally the ideal representation is R of t is like that only, means this is what your R of t. In general, this is what basically, whereas for the unit ramp for this, no, so you will have little bit slowly it will come like this, and from here you will have slowly it will be like this, and then it comes like this basically. So there is a curve nature. Okay, if you draw that, basically it looks like something like this, and then from here it goes steady, it goes like that steady, because from here this is called your steady state. Basically this is called your steady state response. Basically this is what your steady state response, whereas this particular is called as your transient response. This is what your transient response in general. This is what graphical representation of your a response. This is what the time response, and that is the mathematical expression. Sometimes in academic point of view, definitely you may be asked to obtain or derive the expression for the time response. And similarly, I request you to solve for time response of the first order system for that unit parabolic. Let us try on your own, and I will explain you in the next presentation. And however, in the next subsequent presentation, I would like to go for the time response of a second order system, where you will have a lot of excellent time domain specifications, time domain parameters will be there, and you will be expected in GATE examination and UPSC IEX examinations. So far what we have seen in the first order is the basic information only. You will not have any questions in examination, competitive examination point of view. All this what I have explained till now, it is for your academic point of view only. But whereas as far as your GATE examination and then UPSC IES examination and many other competitive examination point of view, the very important is the time domain specification or the time domain response of a second order control system. That I am going to explain you in the next presentation. And however, just I request you to derive the expression or obtain the expression for the first order control system with the unit parabolic as input signal. Let us try on your own. Otherwise, I will explain you in between the subsequent presentations. However, in the next, I will explain you, I will move on for the time response of a second order system, where you will find a lot of excellent, beautiful definitions which will be expected in the competitive examinations. So, by the way, today with this, I am going to finish my presentation. I hope you all understood this concept of a unit ramp input response of a first order control system. And definitely, if you like, and definitely you can like and you can comment on my channel with your positive or negative feedback, whatever it is. And I request you all that don't forget to forward to your friends, to share with your friends, so that every person can go through it. And definitely I expect you all to be benefited and to be have deeper knowledge of these concepts, thereby you can gain and you can excel. Okay, so thank you one and all.